Hi, I'm Persephone Needs.
And I'm Cecilia Chu, and today we're looking at the presence of microplastics in the rivers and streams around Yukon.
Behind us is Mirror Lake. Come with me.
We have been asked to figure out a clear, thoughtful question about markers of the Anthropocene that relates in some meaningful way to a process, object, or landform that we can film at Yukon. Our question is, how do microplastics serve as markers of the Anthropocene in rivers and streams surrounding the University of Connecticut, and what processes contribute to their accumulation and impact on these freshwater systems?
This is one of the streams that goes into Mirror Lake.
The answer to this question is simply because microplastics are a clear marker of the Anthropocene in the rivers and streams surrounding the University of Connecticut, as they are the product of human activity and a novel material, especially related to the production, consumption, and disposal of plastics. The accumulation of microplastics in these freshwater systems is driven by urban runoff, water discharge, and improper waste management. These microplastics are carried by water or rivers in the stores area into water bodies such as Mirror Lake. Once these particles enter the system, they can travel very far and accumulate in sediment and along riverbanks. These microplastics have a profound impact on water quality, disrupt aquatic life, and alter the natural processes of river ecosystems. Microplastics represent not only a visible and lasting marker of human influence, but also a critical issue that requires immediate attention and action to mitigate their long-term effects on the environment. The first marker of the Anthropocene we would like to focus on is rivers and streams, because we are analyzing the presence of microplastics within the river and the stream basin of Mirror Lake, near the University of Connecticut, and how this influences and impacts the natural processes of these freshwater systems. The first Anthropocene curriculum article we looked at to support our findings regarding microplastics is The Technosphere and the Mississippi River. The article The Technosphere and the Mississippi River from the Anthropocene curriculum discusses how human activity, specifically regarding technology and industrialization, has profoundly shaped natural systems like the Mississippi River. It explores the technosphere, which is a global system of human-made materials, technologies, and infrastructure, and how it interacts with natural systems. While the article does not mention microplastics, it provides valuable insight into how human community and human-made elements, including industrial waste, pollution, and technological advances, impact ecosystems like the Mississippi River. Research and data from this article explain that a number of academic studies have related to the idea of humans as contingent parts of a larger system of relevance in understanding the Mississippi as a component of the technosphere. This emphasizes the intertwined roles of humans and the environment. In our project, we are focusing on the negative effect of humans on natural water systems. In addition to using the information from the Anthropocene curriculum article, we looked at two references used in the Technosphere and the Mississippi River. The first reference in our chosen article was from Dynamics of Coupled Human Landscape Systems, where we found further evidence supporting our claim of microplastics' negative effect on freshwater systems. Human impact and alterations on natural environments began thousands of years ago. However, the depth of these changes has changed greatly over the years. As stated, the scale of human impacts on the natural environment, however, is now considerably larger than at any point in history. This article focuses on how human activities interact with and modify physical environments. It emphasizes the idea that if humans cease to exist, these water systems would continue in the same without human intervention. This information relates to our research regarding microplastics in water systems because without human intervention, these water systems would be better off. This unintentional contribution to microplastics in the environment has a greatly negative effect. Not to mention, this wouldn't be the first time humans have negatively impacted the environment. The second reference in our chosen article was from, Is There a Bulldozer in Your Model? This article talks about human intervention in geomorphic processes. The argument is made that active, responsive human processes affect sediment transport during major storm events. This article explains how human intervention can significantly impact landscapes, specifically during storms. There are options such as seawalls and levees that withstand storm forces but do not directly impact the landscape. However, unlike seawalls and levees, a front-end loader functions as an active, responsive physical process of sediment transport unto itself. This is another example of how human intervention affects different environments differently. In our research, we are focusing on the negative effects that are brought upon freshwater by humans. Human activity is directly related to the use and disposal of plastics, specifically how they end up in the water systems. We also explored deeper into the reality of microplastics in What's So Micro About Plastics? This lecture depicts that because they can be incredibly small sometimes, people forget how large of an effect they can have. Microplastics has been seen in all aspects of life on planet Earth. They have spread so drastically since the plastic industry boomed, so much so that pretty much everywhere on Earth is likely to have a trace of microplastics. In rivers and streams, in oceans, on land, and even in our food. People have found microplastics in human stomachs and feces. This highlights the true reach of microplastics. Because of this novel material, animals are dying or becoming ill. The environment is deteriorating, and humans are contracting serious illnesses such as cancer. It is our responsibility to take action and try to limit exposure and the spread of microplastics, especially in our waterways on UConn campus. Thank you for your time and attention taken to watch our video. We hope this was an insightful look into UConn's Anthropocene and how it is affected by microplastics in its rivers and streams. This was produced by Julia Popowski, Cecilia Chu, and Persephone Deeds.